Hello. So here I'm going to cover more of chapter 7.1. Here I'm going to start with the sector area formula. The proof of this is in this week's module, the proof of arc length and area of a sector video by black pen, red pen. So essentially we have the area is equal to 1/2 times your radius squared times theta, but again theta has to be in radians. So in 23 through 24, it says find the area of the sector determined by the given radius r and central angle theta. Okay, so if you continually write down the formula, it will help you to memorize the formula. And then we just put in what we have. So 4 squared is 16. 16 divided by 2 is 8. Include the units. Our centimeters are being squared and area is squared. And then simplify the fraction. Five degrees, convert that to radians. Five over 180 is 1 over 36. So then we have 16 squared. Let's do this. Let's go with that 16 squared. And the 1/2 is 2 and 36. Okay. 3 2s, 3 2s. So 21 is 3 times 7. Being squared, we're going to have 3 squared and 7 squared. And 6. 6 is 2 times 3. And then times by the 11 at the end. So it's all of this times pi feet squared. So this is 11 times 49 times 3. Again, these are in degrees, so let's convert this into radians. Seventeen is prime. Technically, that is your numerator. The denominator is going to be 2 times 18, which is 36. So we have our radius squared times our radians, and then divided by 2. That radian is just redundant. So with calculus, you will get a lot of word problems, and you'll just need to piece together the language in the word problem to solve it. Number 26. In a circle of radius 3 meters, the area of a certain sector is 20 meters squared. Find the degree measure of the central angle. Round the answer to 2 decimal places. So this one's asking us to find a degree measure. So we need to first compute this. We'll get radians, and then convert the radians into degrees. There's our basic formula, but now they give us the area. And they give us a radius. And we just don't know our theta. So if I multiply everything by 2/3, if I multiply everything by the reciprocal, what this would give me is multiply by 2, divide by 3m. There's no degree symbol, so this is radians. So we want to change this into degrees. An unusual, but that is what it is. And how I found that is I took 720 divided by the product of 3 times pi. You can use 3.14, that's fine. Okay. Number 28 that says find the perimeter of the sector and the area of the sector. Well, the perimeter is the distance around, and so we have theta equals S divided by R from earlier in this section. Okay, let's convert 135 into radians. I wanted some more room because this fraction looks challenging. So 135 is like, what is 135? 45? So we have extra 5. I should have recognized 135 degrees as 3 pi over 4. So since that's our arc length, 9 pi over 4, the perimeter is the distance around. So we're going to have 9 pi over 4 plus 3 plus 3. So since I'm adding fractions, let's do this as 12 over 4. And we can even do this as a 12 over 4. So that the perimeter the perimeter is this number plus this number plus this number. Since they all have the same denominator, so I'm just going to add the numerator straight across. area. That 8 is because the angle measure is 3 pi over 4, and then the 4 times 2 is 8. So that the area is equal to angular speed and linear speed. So I also put a video on this in this week's module. The math source where I made that video. Linear speed or velocity is equal to the radius times theta divided by time. And so numbers 29 through 36, you are given the rate of rotation of a wheel as its radius. In each case, determine the following. You want the angular speed, and then you want the linear speed, and then you want the linear speed of a point halfway between the center and the circumference. Okay? So the angular speed is going to be theta divided by time. So if this is our circle, and if you were to rotate this much, you have gone pi over 2 in radians. And if you've gone all the way around, you've gone pi radians, okay, 3 pi over 2 radians, 2 pi radians. So one rotation, you've gone 2 pi times radius. To go 15 revolutions, that's 15 times 2 pi, or 30 pi. So to go around 15 revolutions is 30 pi. Going on 30 pi per second. This omega is going to be 30 pi per second is the angular speed. That's how fast it's going. Then for the linear speed is velocity equals r times theta divided by t. So because we're going at 15 revolutions per second, our theta is going to be 15 times 2 pi, which is 30 pi. 30 pi times the r is 600. Include your units and your time. So the velocity, how fast it's going, is the radius, which is 20, times your theta, which is 30 revolutions. 30 revolutions times 20 is 600. Centimeters is your distance, and that's the frequency, your per second. The linear of a speed point halfway between the center of the wheel and the circumference. Okay, so we're still traveling at 15 revolutions per second, but we're going to change this r down to a 10. So let's call this v1, that's your first velocity, and we'll call this the second velocity. So now the radius, instead of being 20, is 10. We still have our 30 pi revolutions per 1 second. So as you're spinning around this wheel, your linear speed increases as you go out. Thank you very much. Please go to tutoring.